So we're continuing our review of exam-style questions for Mohr Circle. We already went through a video on terminology, which you should look at. We already looked at a video number 1 on a set of interesting conceptual short Mohr Circle problems. And so this is just another set of example problems, again, along the same vein, but just giving you pieces of information about Mohr Circle than asking you to find something else. So read the examples, follow the examples, learn them. They're tricky. So look at it once, look at it again, look at it a third time so that you can read the problem correctly, understand what you're being given, and understand what you're asked to calculate and know how to get there. And again, it's tricky. I admit it's tricky. And so, I mean, I know how to work these problems, and it's tricky. So, which is why we're practicing, is to get you going, to get your brain wired properly, to get these problems right on your exam 4. And so these are additional simple Mohr Circle problems. And so here's a problem. It gives you a center. So I center is 32 inches to the 4th, which is I average. It tells you that axes P and Q are perpendicular to one another. It gives you IP is 20 and asks you to find IQ. You're going, okay, so what do we do with this? So actually one principle that you can use is that, remember, we have an invariant property for our rotated coordinate systems, that basically Ix plus Iy is equal to Imax plus Imin, which is equal to IP plus IQ for any set of perpendicular axes. And so this problem says I center is 32. So I center is I average. And so IP plus IQ divided by 2 is 32, which is what you're given. Multiply through by 2. And so IP plus IQ is equal to 64. You're given IP is 20. And so IQ is equal to 64 minus 20. So IQ is 44. That's not straightforward. Once you see it, you see it. But that's why we're practicing, okay? These are the concepts that you need to have in your brain. Here's another one. So you have a set of axes PQ. And again, these guys are 90 degrees from one another on the cross section, and they're 180 degrees apart on Mohr Circle. You're given the moment of inertia of point P is 16. And you're given the product of inertia IPQ is 6. And you're given I center. So we're asked to find the angles from the P-axis to the major axis, which is 2I max, and the angles from the P-axis to the minor axis, which is I min. So you're given enough information to draw. So if you draw a Mohr Circle, the center is at 12. Point P is up here, which is 16 and 6. And so the angle to I max is 2 theta P1 on Mohr Circle. The angle from P to I min is 2 theta P2 on Mohr Circle. If you draw this triangle, this right triangle, the vertical side is 6. The horizontal guy is 16 minus 4. I'm sorry, 16 minus 12, which is 4. So once you draw this triangle, 2 theta P1 is the inverse tangent of 6 over 4, which is, so 2 theta P1 is 56.3 on Mohr Circle. So divide that by half. So theta P1 on the original element, or the reference area, is 28.2. And so that's the angle clockwise or negative from our P-axis to I max, or to the major axis. The angle from P to the minimum I, or to the minor axis, or to the minor principal value, is this guy. And so on Mohr's circle, this is 180 minus 56.3, which is 123.7 on Mohr's circle. Divide that in half, and you get theta P2 on the original area is 61.9 degrees, basically, clockwise or positive from P to the I min or to the minor axis. Again, go over and over this till you can get this. Here's another one. So you're given the diameter of Mohr's circle is 8. You're given the center is 12. You're asked to find the product of inertia about a pair of perpendicular axes rotated 45 degrees from the principal axes on the original area. You're going, okay. Well, you can set up Mohr's circle. So the center is 12. The diameter is 8, which means that the radius is 4. Oh, I didn't draw that right. The way I drew this circle, I drew it with the radius is 8. So let's just say the radius is 8. So the diameter would be 16. Radius is 8. So the circle that I drew was 12 at the center. I max is 20. And I min is 4. It says find the product of inertia about a pair of axes 45 degrees from the principal axes on the original area, which basically means 90 degrees from the principals on the Mohr circle. Well, 90 degrees on Mohr circle takes you up to the top of the circle and the bottom of the circle. And so these guys have a product of inertia that's equal to the radius, which is 8 on this guy. And then finally, one more conceptual problem. So this problem says the diameter of Mohr's circle is 84 centimeters to the fourth. The product of inertia about a set of ij axes is 28 centimeters to the fourth. Determine the magnitude of the product of inertia about a set of LM axes rotated 37 degrees counterclockwise on the cross-section. Not easy. So let's draw the circle. So basically you've got a circle. It said the diameter is 84, which means that the radius is 42. So now you have a circle. You know the radius is 42. And then we're told that the product of inertia about a set of ij axes is positive 28. Now, it doesn't tell you whether that's at over here or over here. I just drew it here. So it gives you a positive 28 here at some ij set of axes. Remember, ij are perpendicular on the original area, but they're 180 degrees apart on the circle. So for some point I, we have a product of inertia, which is positive 28, and we know the radius, which is 42. So that actually gives us enough of that diameter and that side, and knowing it's a right triangle gives us enough information to find this angle. And so the sine of 2 theta is equal to 28 divided by 42, or 2 theta is equal to the inverse sine of 28 over 42. So 2 theta here is 41.8 degrees. And that's on Mohr's circle. And so the problem says, find the magnitude of the product of inertia about a set of axes rotated 37 degrees counterclockwise on the cross section. So that's 74 degrees on Mohr's circle. So then we're going to start here, and then we're going to take 74 degrees counterclockwise. And so if this is 41.8, and this is 74, so 41.8 plus 74 is 115.8, and then minus, so 180 minus 115.8 is 64.2 degrees. So this angle here is 64.2 degrees. And so this point L, it was asking for the LM axes. And so this guy's L, and this guy's M. This angle is 62.4. This hypotenuse is the radius, which is 42. So the product of inertia at L is basically equal to the radius times the sine of 64.2. And so the product of inertia is 37.8 centimeters to the fourth at L. If it asks you for the moment of inertia at L, then you could basically take that's equal to, did it ever give you a center? Oh, so it actually didn't give you a center. It didn't give you a center value. So we actually don't know where the circle is located on the moment of inertia axis. So we don't have enough information to get the center or Imax or Imin. All we have is basically the information to get product of inertia values. Interesting. Interesting. So again, these are a number of simple Mohr circle conceptual questions where you're taking pieces of information and then building out the ideas to get the answers to the questions. They're tricky. They're not straightforward generally, and which is why we're preparing for them. We're getting your brains wired so that you can properly work these problems. So if this is confusing to you, read it, reread it, practice it. Think about what pieces of information can I be given, and from those pieces, where can I go? Where can I get information?